Hey guys, how are we doing today? My name is Auston F, and today we'll be doing something with u substitution with two separate functions, alright? Let's get started. So first our function f of x is equal to 2x over 1 plus x squared. Now, when you graph this function, we're trying to find the area underneath it from the interval -2 to 2. Cool? Alright, so when you graph that in graphing calculator, you'll get a function that looks like this. It has an asymptote at y equals 0, and it goes like this, dips down, goes through the origin, and back this way. Alright? And so what you end up getting is you have this area from -2 to 0 is the exact same as area from 0 to 2 right here. Okay? And so obviously we add these areas up because this area is below. It's going to cancel out the area that's above it. Alright? To make it 0. So just looking at the graph, we're going to get from -2 to 2 on f of x, the area beneath the curve is 0. Now I'm going to prove this to you using u substitution right over here. Okay, and those look a lot. I'm going to go through everything. Ready, set, go. Let's do this. Alright, so we have a function right here, right? You have -2 to 2 of f of x, as we have over here, d of x. Now, we're going to make our u something that the derivative of will equal another portion of the function. Let me show you what I mean. So u is going to be 1 plus x squared, just we have the denominator here. And we take the derivative of this, again, using power rule. So, take the derivative of this using power rule, and you get 2x. Okay? And so you simplify this to get du equals 2x dx. Now, I want you to notice something here. This is equal to the top portion of our function right here. 2x dx, 2x dx. Meaning that we can replace this top function with du. Cool? Alright. So once you do that, we replace that with du and replace the bottom with what we did before up here. So u equals 1 plus x squared. We're replacing the bottom with the u right here. Okay? Now, I'm going to show you a quick function over here that we did in my previous video, but just to refresh your memory on it. You have ln of u equals 1 over u. Sorry, the derivative of ln over u, the derivative of ln u is 1 over u. Okay? So that being said, we know the antiderivative of 1 over u, just going backwards, is ln u. Okay? Now there's two ways you can go after this step. You can use the indices they give you and plug in your u back in over here, or you can create new indices based on your variable u, meaning that you have to plug in your indices, -2 and 2, into your u function up here and get new indices. So in this case, you get ln absolute value of u because you can have absolute value of a negative number, and you have 5 and 5. Over here, in my case, I'm going to be doing it with the original indices, plugging u back into my equation here. Okay? So I'm substituting u in 1 plus x squared over here. Cool? Alright. So we've done this. We've plugged in our upper bound and lower bound. Again, you always do upper bound plugged into the function, subtracted from the lower bound. So the top minus the bottom. That's the way I like to think about it. Okay? So we get ln 5 minus ln of 5 is equal to 0. Just like we got right over here. Okay, guys? So, again, you get 0 using u substitution, which our u is 1 plus x squared. Get the same answer by just graphing the function and finding the area from -2 to 2. Alright, we move to our second problem for today. Alright, so our second problem here is a little bit of a bear. So we have from 0 to 1 over rad 3 dx 1 over 1 plus 4x squared. And that can be rewritten in a way to use u substitution, because we're going to be using u substitution today, as this. From 0 to 1 over rad 3 of d of x over 1 plus 2x squared. Okay? Now, the reason I wrote it like this is because, remember from our last video, this is one of our trig identities we need to remember. The derivative of arctan of x is equal to 1 over 1 plus x squared. Now, if you look at this function here, you look at this function over here, there's some similarities, right? All I did here is plug in a 2x for x. And that's pretty significant and useful, because that means we can use u sub and just make u will be plugged in for x over here. Alright, so then u equals 2x. Again, just like I did over there, I took the derivative of this function, got d of x equals 2, and then divided this 2 over, so I get 1 half du is dx. Again, I'm trying to replace this numerator right here, I'm trying to replace this dx. So dx here is 1 half du, so I put my 1 half on the outside here, I put my du on top here, and I replace this portion of the function with u. Alright, because u is 2x here. Alright, so then from there, we do this we did over here. we do keep our 1/2 on the outside just to make the math a little bit simpler. We do 1/2 out here, arctan 2x, 1 over square root of 3 over 0. Again, I did that plugging my u back in here so I can use the original indices. Very important doing these equations, okay? Make sure you're using the indices that correspond with the variable you're using. Very, very important. Don't forget that. Okay, so now we did that. We plug in our lower bound minus upper bound. Again, I distributed the 1/2 to both parts here. So upper bound minus lower bound. All right, we end up getting this 1/2 arctan of 1 over square root of 3 so minus 1/2 arctan of 0. Okay, and this ends up being 0, which we have right here. And then 1/2 arctan of 1 over square root of 3 is your final answer. All right, guys, if you need to review, go ahead and back up the video so you can review which parts were confusing. Leave any comments in the section below. I appreciate you watching this video tonight. Have a great day, and don't forget to be awesome. Auston out.